Hello, students. In this session, we will be discussing differential equations. So let us begin with the questions. I hope you already know the three types, order and degree, because if you don't, then you should go and revise the basic differential equations, the board level questions, and then jump into these questions. So we'll take the first question, students. Question number 11. If you look at question 11, you must be getting a feeling it's such a complicated equation, the given equation, the integrating factor, everything is looking so complicated. But this question is actually super easy if we just focus on the important details. When I say important details, when we talk about integrating factor, students, I'll not have a look at Q. The focus will never be on Q because integrating factor is all about e raised to integration P. So you need not worry about this complicated thing. We'll not be using it at all. The integrating factor is given. Let me first simplify that because the simplification of that is going to give us a very beautiful expression. So we have root e raised to log x the whole square. Root e, students, is e raised to half. So this is e raised to half log x the whole square. So this, students, is the integrating factor. Now, if you look at the given differential equation, the standard format of every linear differential equation is dy by dx plus px. So we'll have to get rid of this dy by dx. So here, students, so we'll have to get rid of this x, which is right next to dy by dx. So we'll divide everything by x. So the second term becomes y into p by x. And then we have something on the right hand side. The integrating factor, students, is e raised to integration p dx, where p, students, is the coefficient of y. What is the coefficient of y? Oh, here it's p by x. So it's e raised to integration of p by x. So students, do you understand this integrating factor and this integrating factor are the same? So therefore, we can say that this half log of x the whole square is same as integration p by x. So here I'll write it as half log of x the whole square is equal to integration of p by x. To solve this very easily, students, the best method is to not think about integration, to just differentiate this equation. See, we can't integrate the right hand side. Don't be mistaken, p is not a constant over here. If you're thinking integration of right hand side is p log x, you're wrong. So here we'll have to directly differentiate. I'll take the derivative. Derivative on the left is 2 log x into derivative of log x is 1 by x. And derivative of integration is, students, as good as p by x. We're done with the sum. You cut the x, you cut the 2, p is log x. So that is the correct answer. P is log x, option C. With that, students, we complete this question. Let's proceed to the next one, which is question 44. Assertion and reasoning question. Degree of this differential equation cannot be determined. Now, students, if you're looking at this equation, if you think degree is 2, just be careful. They have used this very smart trick. They have written dy by dx and dx by dy. Remember, the small details in MCQs and assertion reasoning will matter. So students will have to simplify this first a bit. So we have a into dy by dx the whole square plus, do you know this rule, students, that dx by dy is same as 1 upon dy by dx? And we have this equal to c. We'll simplify this, students, because dy by dx cannot be kept in denominator. So we'll take the LCM, I'll multiply it over here. So we have a into dy by dx, the whole cube, plus b, the whole upon dy by dx is c. That dy by dx will go on the other side. So that is c into dy by dx. Now, students, in this case, the degree of this differential equation is going to be 3. It can be determined as 3. Further, they are saying if each term involving derivative of a differential equation of a polynomial, then the highest exponent of the highest order derivative is called degree. That is actually the definition of degree. And therefore, assertion is true. Reasoning is true. And reason is the correct explanation for the assertion. So it's option A. With that, we complete this one. Let's move ahead to question 76. In question 76, students, a child is solving an equation. This equation is given and finds that this is the solution of the following differential equation. We have to justify his answer. So here, students, you have to do a very simple thing. We'll not be solving this differential equation. The differential equation is 1 plus y. I hope you know this rule that y double dash means second derivative, that is d2y by dx2. Plus y dash the whole square is basically dy by dx the whole square. I hope you already know this notation. This is the differential equation given. We can't solve this because in grade 12 syllabus, we don't have the solution. We don't have the methods of solving the second order differential equation. And hence, students, we can't solve this. So our focus will be on finding the differential equation, forming the differential equation, using the given equation x square plus y square equal to 1. This is actually, students, a basic case of derivative proof based question. You have to find dy by dx, you take the derivative first. So here the derivative is going to be 2x plus 2y dy by dx is equal to 0. When you divide by 2, you get x plus y dy by dx is equal to 0. This is the derivative. You take the second derivative, students, and we are done. For second derivative, we'll now again differentiate this. Derivative of x is 1. Do you understand, students? Derivative of this is by UV rule of derivative. So it will be y into derivative of derivative. We'll now keep dy by dx out and it will be derivative of y. So now students, when you solve this, we have 1 plus y into derivative of derivative, students, is second derivative. So that is d2y by dx2. And plus this is dy by dx. This is derivative of y, which is again dy by dx. And hence it is dy by dx, the whole square. And that's equal to 0. So this, students, is the final answer. And we have already proven this. We'll proceed, students, to next question 78. Question 78, students, if you look at this question, you might be thinking, what kind of question is this? But it's not that difficult. Provided you know one concept from grade 11 of lines passing through origin. Do you remember this basic equation of line, students, y equal to mx plus c? And do you know that if it passes through origin, then y is 0, x is 0, and then when you substitute, you will get c is 0, which means the equation of line passing through origin is of this format, y equal to mx. If we can prove this, then we can say it's a line passing through origin. Now we look at this question 78. They have given x dy minus y dx. This is the equation given. We have to solve this differential equation. It's a very simple case, students, of basic variables available. X dy is equal to y dx. So 1 upon y dy is equal to 1 upon x dx. When you integrate both sides, it's ln y or log y. You can write it as log y also, don't worry, but the base is e. So log y is equal to log x. Because both are log, I'll take it as plus log c. So now, students, on the other side, it is log of c into x. When we remove the log, we get y is equal to cx. I'm sure, students, everyone knows the variable separable form, and you could have reached till this point. The only knowledge that you need after that is that if it is y equal to cx or y equal to mx, the constant term is not there, which means the lines pass through origin. And that proves this answer. Next, we'll move to question number 79. In question 79, students, they're saying df by dx is equal to 2f. We have to find the function f, given that f of 0 is eq. It's again a very simple case of differential equations. We'll solve this by variable separable form. We have df by dx is equal to 2f. I'll take f in the denominator, students. So we have 1 upon f df is equal to 2 dx. When you integrate this on both sides, students, you will simply get that log mod f is equal to 2x plus c. We have to figure out what is c, students. Now, when we say f of 0 is equal to eq, we'll have to first find f from here. Do you understand the base is e over here, students? So f is going to be e raised to 2x plus c. So the final f of x, students, that we have is equal to e raised to 2x plus c. Now, when we take x is 0, students, when x is equal to 0, do you understand we'll have f of 0 is equal to e raised to c. F of 0 is e cube, which means c is equal to 3. So, students, here we get the value of c. C is 3, which means the final function f of x, we'll substitute it back in this, is e raised to 2x plus 3. So that, students, is the final answer. Next, students, we move to this question number 105. So we have to solve this differential equation. It's a very normal differential equation. We'll use the basic rules, the 3 forms you should know, so that you can identify which one is this. If you look at the structure of this question, it's clearly a linear differential equation. So here, students, what we'll do is we'll first divide everything by cos square x so that we have only dy by dx left. So we have dy by dx plus y upon cos square x is y sec square x, and we have tan x upon cos square x, which is tan x sec square x. So, students, P is equal to sec square x. I hope you know the formulas. If you don't, you keep the formula list with you. Q is equal to tan x sec square x. We'll first find the integrating factor. The integrating factor IF here is e raised to integration P dx, which is e raised to integration sec square x dx. Integration sec square, students, is tan. So this is e raised to tan x. So here, students, we get the integrating factor. It is e raised to tan x. Now, students, will solve this. The solution is y into IF is equal to integration of q into IF. So it's y into e raised to tan x is equal to integration of q here, students, is tan x into sec square x, and we have e raised to tan x. Solving this, students, is super easy. You can easily solve this by taking tan x as t. On the right hand side, when you take tan x as t and you differentiate, you'll get sec square x dx is dt. So this part will become integration t e raised to t dt, because sec square x dx will become dt. So here, students, we have integration t a raised to t, which can be solved with UV rule, integration by parts. You complete that, students, and you substitute t at the end. You'll get the answer. I hope you already know how to solve this part, y of pi by 4. It means you have to substitute x is pi by 4 at the end and find c. I'm sure you can manage this. It's a normal board level question. If you have any difficulty, you can comment in the text box. I'll get back to you. That leaves us with the last question, students, from differential equations, question 133. Question 133, students, if you look at the question, we'll come to the subparts, but if you look at the question, it is clearly a homogeneous differential equation. I hope you know this trick to identify if we have sine of y by x, cos of y by x, or log of y by x, or e raised to y by x, or something of y by x, then that is definitely a homogeneous differential equation where we substitute y is equal to vx. Now, in the first part, they are saying transform this equation in this format, dy by dx is equal to f of y by x. So we have to make dy by dx the subject and take everything on the other side. Use appropriate substitution, so that will be y equal to vx. Then you have to convert it to variable separable form, and then you solve, you get this answer, sec of y by x is equal to xy into a constant c. Students, I want you to complete this on your own. It's a basic 6-marker which comes every year in boards. I'm sure you have prepared many such questions. There's nothing difficult or different in this question. If you still find it difficult to solve, you can comment in the chat box. I'll get back to you with the solution. With that, students, we complete the questions from differential equations. In the next session, I'll see you with questions from probability. Thank you.